We are on to chapter 12. This is the last chapter we're hopefully going to get to before spring break. So there's that to look forward to. There is some math, but not in the first two lessons. So that's also good news for you. So let's get started. I'm just going to kind of share the screen. We'll go through the PowerPoint. I will post these notes for you. So if you're not getting absolutely everything as we go through, you can go and find the notes online. You'll see the slides online on Google Classroom, and you can fill in your notes from that, anything that you've missed. Okay, I'll also post the video. So if you're not sure what I meant by something, you can go back and rewatch that part of the video. This section shouldn't take us very long. A lot of it should be review, hopefully, because we're discussing the types of mixtures. Some of it will be new, but some of it will not be. So one type of mixture is called a solution. A solution a solution is another name for a homogeneous mixture. So we've talked before about homogeneous and heterogeneous mixtures, or homogeneous and heterogeneous. So in a solution, you have two or more substances that are all the same throughout. Okay, so they're mixed together very evenly and you cannot tell them apart. So that's what it means by uniformly dispersed throughout a single phase. Okay, so this is like when you dissolve salt in water, you can't see the salt particles anymore. Okay, you have that one phase, that aqueous phase, where you have the water and the salt all together, very evenly mixed. Okay, so when we are talking about making solutions, in order to make a solution, one substance has to be soluble in the other substance. Soluble means we can dissolve it. Okay, so like you can dissolve salt in water. Salt is soluble in water, but you could have something that's insoluble. So for instance, oil. Oil is insoluble in water. It doesn't dissolve, it doesn't mix. Okay, we actually have a slightly different word that we use when you have two liquids, but we'll get to that later. Okay, so soluble, you can dissolve it. When you have a substance that is soluble, the substance that gets dissolved is the solute. The substance that does the dissolving is the solvent. Okay, so in our saltwater example, the water is the solvent and the salt is the solute. Okay, so this applies to when you're trying to clean something up. Okay, in order to clean something up, it has to be soluble in your cleaning substance. Okay, if it's not soluble, it doesn't really, you can't clean it off of the thing. So water does a pretty good job, but sometimes water won't get things off, like permanent marker. Okay, so like on the whiteboard, if I wrote on there with permanent marker, I can't use water and take it off, but I can use rubbing alcohol because the permanent marker is soluble within the rubbing alcohol. Okay. All right, so there are many different types of solutions and there's all sorts of possible combinations. So you can have a solution that is a gas, a liquid, or a solid. So most of the solutions we think of are going to be liquid solutions, something dissolved in water most of the time. But you have a gas solution like air. Air is a mixture. It's a single phase of several gases all together. Okay. So it's a gas solution. Another example of liquid solution, you have ethanol. So this is a liquid solute in a liquid solution. You've mixed ethanol, which is ethyl alcohol, and basically just diluted it with water. But you can have solid solutions as well. So when you have, for instance, gold, this is 14 karat gold, and it's a mixture or a solution of silver and gold particles. Okay. So the greater the number, the more pure the gold or the silver or whatever substance, whatever precious metal you're looking at. And but most of the time they are a mixture still. You very rarely find them like totally pure. Okay. And there's many possible combinations between the states. So we've talked about a solid solute in a liquid solution, dissolving salt into water. We've talked about liquid and liquid, here's solid and solid. You can have gas dissolved in liquid. There's a lot of different possibilities, okay? And so there's actually a chart in your book that gives you the solute and the solvent for liquids and for gases. Whichever one, if like you have a liquid dissolved in a liquid, whichever one is the greater percentage of your solution is the solvent, and the other one is the solute. Okay, so for this example, the ethyl alcohol would be the solute, and the water is the solvent. Okay. So that probably also applies when you have two gases, or sorry, two solids. The greater proportion, whichever one is making up the greater proportion, is the solvent. Okay. We can also describe our mixtures as being a suspension or a colloid, and they are different from solutions. So in a suspension, the particles will settle out of the mixture unless you constantly stir it. So even like orange juice, right? Like if you don't shake it up, all of the orange juice stuff has settled to the bottom. So if you don't shake your juice before you pour it, it tends to become like watery that you get, and then at the very bottom, you get all of the orange juice. Okay. Muddy water is another example. The mud particles settle out. Okay. Colloids. So solutions have very tiny particles. Suspensions have very large particles. Colloids are in between. So colloids have these particles that are there, but they're not really fully like dissolved. So the colloid particles, so what we have here are two phases, right? Because they're not really totally dissolved. They don't make a single phase, but they also don't totally settle out into two distinct phases like a suspension would. So the colloid particles make up the dispersed phase, and the water usually is the dispersing medium. So basically with a colloid, you would have like a cloudy substance. And even when you pour it through a filter, it's still going to be kind of cloudy. With a suspension, you can filter out all of the mud, and you typically have kind of a clear water. Although sometimes when you have that muddy water, like the water layer still is kind of cloudy, because you still have some of these colloid particles. So examples of colloids: milk is actually a colloid, mayonnaise, and smoke. Okay, so if you kind of think about those things, that's what we're talking about for a colloid. Hairspray is another one, paint. And just like with solutions, your colloids can be made up of your dispersed phase, and your dispersing medium could be two different states of matter, or they could be the same state of matter. Okay. One way to recognize a colloid is that colloids can undergo what's called the Tyndall effect, which is where the particles are big enough to scatter light. Okay, so you can't always necessarily see, they kind of look like a solution, like they kind of look all the same throughout, but then when you shine a light through it, in this picture on the left, this is not a colloid, this is a solution, so it doesn't really disperse the light very much. But in the colloid, you can see the light as it's bouncing off the particles. Okay, so fog makes a colloid. And so when you're driving through fog, right, and you turn your headlights on, you're not supposed to turn them on bright, because all it's doing is reflecting that light back at you. Okay, because the particles, the fog particles, are just scattering the light. Okay. In your book, it gives you gives you this. It gives you another chart about colloids, though, where it talks about, if you have a solid that's dispersed in a liquid like paint or mud, okay, and gives you examples of similar to what we talked about with, you can have, a liquid dissolved in a solid. Well, you could have a liquid dispersed in a solid to make what's called a solid emulsion, like butter. Okay, and that's a colloid. It's a type of colloid. Okay. This chart is just showing the difference between the three types of not types of solutions, types of mixtures: solutions, colloids, and suspensions. Solutions, you can see, are the only ones that are homogeneous mixtures. The other two are heterogeneous. Okay. So solutions have the smallest particles, colloids are intermediate, suspensions are the largest. And then it gives you some of the properties of them, some of the things that you can look for, or some of the things you should note as the keywords of how do I recognize that this thing that's being described is a solution or a suspension or a colloid. So like solutions and colloids, you can't separate them by filtration. If you pour salt water through a filter, you're still going to have the salt and the water in that filtrate, okay, and what goes through the filter. And the same thing with colloids. If you tried to do that with milk, you're still going to have milk after you pour it through the filter. But a suspension, you could separate mud, right? If you poured muddy water through a filter, you would get still kind of some yucky water, but you would get water, and the mud would be on the filter. Okay. And then colloids are different from solutions in that they scatter light. Suspensions can scatter the light, but they're not transparent, so they're usually pretty obvious that, hey, this is a suspension, because you have like two very distinct layers. All right, and then the last thing that we need to cover today is electrolytes and non-electrolytes. So much like their name sounds, electrolytes conduct electricity, and non-electrolytes do not conduct electricity. And that just really relates back to which type of compound they are made up of. So what did you dissolve in your solvent? And that's going to determine whether or not it's an electrolyte, if it's a weak electrolyte or a very strong electrolyte. And that has, so ionic compounds, if you remember, way back when, if you dissolve an ionic substance in water, it will conduct electricity, right? Because it creates those charges. They break apart into their ions. Whereas a non-electrolyte, like a molecular compound, will not conduct electricity because they don't break apart, or at least not very much, into any sort of ions. Okay, so there's no charges. So this is showing you sucrose, which is table sugar. You dissolve sugar in water, and I think we found that glowed just a little bit when we were looking at that. Acetic acid, which is vinegar. Vinegar is a very weak acid, and so you don't get a whole lot of what we call dissociation. It doesn't break up very much, not like sodium chloride, or in this case, hydrochloric acid here on the far right. So hydrochloric acid is a very strong acid, so it almost completely breaks apart into its ions. Okay, so it would glow very, very brightly if you were testing it with a light bulb. Okay, so that is the end of lesson 1. Okay, the homework is pretty straightforward for this. So you're matching at the top, and then for question 2, this is not multiple choice. Not multiple choice for question 2. It's giving you 3 properties, and it wants you to decide if this is a suspension, colloid, or solution, and explain your answer. Okay, give some definitions, give an example you can look in your book. On the second page, we're talking about electrolytes. Okay, so figuring out for each one, okay, indicate whether each one will conduct electricity and then tell me why or why not for each one. Okay, and then it's multiple choice for the end. All right, so there's only 10 questions. Shouldn't be terribly long or difficult. But good luck on that. And message me with questions. I will try to get back to you as soon as possible.